In this video, I will walk you through free response question number 6 from the 2008 AP Calculus exam. We will talk about equations of tangent lines, the relative max and min, points of inflection, and limits. Let f be the function given by f of x equals natural log x over x for all x greater than 0. The derivative of f is given by f prime of x equals 1 minus natural log x over x squared. Part A. Write an equation for the line tangent to the graph of f at x equals e squared. Whenever they ask me to write an equation of a tangent line, I like to use point-slope form, which looks like this. Y minus y1 is equal to the slope times x minus x1. This reminds me that I need two things, a point and the slope. Let's start with the point. They told us to find the equation of the tangent line at x equals e squared. So we know that the x value is e squared. We just need to find the y value that goes with it. We will use the original function to find the y value. So the y value will be f at e squared. So that's natural log e squared over e squared. But natural log and base e cancel each other out. So in the numerator we just have 2. So 2 over e squared. And that's it. This is the y value. So I'm just going to put 2 over e squared. So this is the point. Now we need to find the slope. Well, if we've learned one thing so far in calculus, it's that when you hear slope, you should be thinking derivative. So we will use the derivative in order to find the slope. So we need to find f prime at e squared. So here is f prime at e squared. But as I mentioned a moment ago, natural log and base e cancel each other out. So we will just have 2, or rather 1 minus 2. E squared squared is e to the 4th power. So we end up with negative 1 over e to the 4th power. This is the slope of the tangent line at e squared. So now we can write the equation of the tangent line in point-slope form. Y minus y, so y minus 2 over e squared, is equal to the slope, so negative 1 over e to the 4th power, times x minus x, so x minus e squared. So that's it for part A. Part B. Find the x-coordinate of the critical point of f. Determine whether this point is a relative minimum, a relative maximum, or neither for the function f. Justify your answer. Remember, a critical point of f of x is where f prime is equal to 0, or where f prime is undefined. They gave us f prime in the setup of this problem, so here it is. Also remember that the function is only defined for x greater than 0. Since we are given that x is greater than 0, there's no way that the denominator is going to equal 0. So we don't have to worry about f prime being undefined. So let's just focus on where f prime is equal to 0, and that'll be the critical point. We know a fraction will only equal 0 if the numerator is equal to 0. So f prime will equal 0 if 1 minus natural log x is equal to 0. Adding natural log x to both sides, we get 1 equals natural log x. And I'm sure you won't mind if I flip that around and write natural log x equals 1. Solving this for x, we can exponentiate both sides of the equation. In other words, we can put a base e on both sides, making these into exponents. The base e and the natural log cancel each other out because they are inverse operations. So on the left side, we just have x, and then e to the 1 power is just e. So this is the x value of the critical point that we were looking for, but now we need to determine whether this point is a relative minimum, a relative maximum, or neither. In order to do that, let's plot this point on a number line and make a sign chart so we can figure out where f prime is positive and where it is negative. So here's E on my number line. I'm going to put 0 right here because the domain starts at 0, not including 0, so I'll put a parentheses to remind me of that. I'm going to need a row for each factor in this quotient, so I'm going to need one row for the numerator, 1 minus natural log x, and another row for the denominator of x squared. So let's think about whether 1 minus natural log x is positive or negative in each interval. Remember that natural log of e is equal to 1, because natural log e is really log base e of e, and the power that turns e into e is 1. So natural log e is 1. So when x is e, then I have 1 minus natural log e. That's 1 minus 1, that's 0. So right here at e, we have a value of 0. If x is anything less than e, or I should say between 0 and e, then this value is going to be less than 1. So I'm going to get a positive value. So remember that e is approximately 2.72. So what if we pick an x value like 1? So the natural log of 1 is 0, and of course 1 minus 0 is positive 1. So we get a positive value when we are talking about an x value that's between 0 and e. When you have anything bigger than e, then this expression is going to be bigger than 1. And we will have 1 minus a number bigger than 1, so that's going to be negative. X squared is going to be positive no matter what, because we are talking about values that are greater than 0, and we're squaring them anyway. So definitely positive. What about the overall sign of f prime? In this first interval, we have a positive divided by a positive, so that's a positive. In the second interval, it's a negative divided by a positive, so that is a negative. What we are doing here with the sign chart is called the first derivative test, and we can use it to figure out whether or not this critical number is at a relative minimum or a relative maximum. So the idea is if f prime is positive, that means that the original function must be increasing in that interval. If f prime is negative, the original function must be decreasing. So if the function goes from increasing to decreasing, we are looking at a relative maximum. So here's how we would summarize and justify. F of x has a critical point at x equals e because f prime at e equals 0. F of x has a relative max at x equals e because f prime changes from positive to negative. Notice for this justification, I don't say anything about f of x is increasing and then decreasing. This is the first derivative test that we're using. So just say f prime changes from positive to negative. The graph of function f has exactly one point of inflection. Find the x-coordinate of this point. Here is the key fact that you need to memorize. A point of inflection occurs when f double prime changes signs. Therefore, our strategy for finding the location of a point of inflection will be number 1, find f double prime, number 2, make a sign chart, and number 3, see where f double prime changes signs. Also, remember that when we make the sign chart, we will be finding where f double prime equals 0 and where f double prime is undefined. In the setup of the problem, we were given f prime. So let's use this to find f double prime. This is a quotient, so we will need the quotient rule, which goes low d high less high d low. Draw the line, and down below, the bottom squared will go. I'm hoping this is not the first time you've heard that little poem, but here it is again. Low, d high. Low means the denominator. D high means the derivative of the numerator. The derivative of 1 is nothing, so I write nothing. Now the derivative of negative natural log x. I'm going to bring down the negative sign, but the derivative of natural log x is 1 over x. So that's low d high, less means subtraction, high d low. High is the numerator, 1 minus natural log x, and d low is the derivative of the denominator. So this will be 2x. Draw the line, and down below the bottom squared will go. Well, x squared squared is x to the 4th power. So this is an expression for the second derivative. I'm just going to simplify it a little bit. You'll notice that I moved the 2x to the front of the parentheses to make it easier to do the distributive property in a moment. But first, let's go ahead and multiply x squared times negative 1 over x. I will still have the negative sign, but this x in the denominator will cancel out one of the x's in the numerator. So it'll just be negative x at this point. When I distribute the 2x, I'm really distributing negative 2x. So keep that in mind as I multiply negative 2x times 1, which is negative 2x, but then negative 2x times negative natural log x. A negative times a negative is a positive. So I get positive 2x natural log x. I see that we have like terms right here. So let's combine those on the next step. What else can we do? I see that we have a common factor of x in the numerator, so let's just factor that out. And now we notice that the x that we just factored out in the numerator will cancel out one of the 4 x's in the denominator. So this is the simplified form of f double prime. To make the sign chart, we need to find where f double prime equals 0 and where f double prime is undefined, because any of those solutions will be what we plot on the number line to make the sign chart. Let's start with f double prime undefined, because we can actually get that out of the way very quickly. F double prime will be undefined when the denominator is equal to 0. So clearly that means that x would equal 0. But there's a problem with that. We were given in the setup that x is greater than 0. So x equals 0 is outside of the domain. So we just need to find where f double prime is equal to 0. A fraction will only equal 0 when the numerator is equal to 0. So we have negative 3 plus 2 natural log x equals 0. Adding 3 to both sides gives us 2 natural log x is equal to 3. Dividing both sides by 2, we have natural log x is equal to 3 over 2. To cancel out the natural log and leave x by itself, we can exponentiate both sides of this equation. We can put a base b, causing each expression to become the exponent. Base e and natural log x cancel each other out. These are inverse functions. So on the left side, that will leave x, and on the right side, we have e to the 3/2 power. So this is where f double prime is equal to 0. So let's make our sign chart. Here we have the e to the 3/2 power on the number line. I'm going to include 0 because that's where the domain begins. We are told that x is greater than 0. We will need a row for the numerator of f double prime and the denominator. So I will put negative 3 plus 2 natural log x here, and I will put x to the 3rd power here. So let's decide whether negative 3 plus 2 natural log x is positive or negative in each interval. As we decide, remember that e to the 3/2 power is e to the 1.5 power. So picking a test value in the first interval, we could use e to the 1 power, which is just e. Substituting e for x, we have this. I'm actually going to leave it as e to the 1 power to make it clear that when we have natural log and base e, they cancel each other out, leaving just the number 1 behind. So we would get -3 plus 2 times 1. Obviously, this is just -3 plus 2, which is a negative number. So negative in the first interval. How about a test value that's bigger than e to the 3/2 power? Bigger than e to the 1.5. How about e squared? So this would be -3 plus 2 natural log of e squared. Well, again, the natural log and the base e cancel each other out. These are inverse functions. That will just leave the 2. So we have -3 plus 2 times 2. But this is -3 plus 4, which is a positive number. Glancing at the second row, x to the 3rd power, remember that we are only dealing with values of x that are greater than 0. So x to the 3rd power will be positive in both intervals. That means that the overall sign of f double prime will be negative in the first interval and positive in the second interval. So we can see that f double prime does change signs at e to the 3/2 power, which means that there is a point of inflection at x equals e to the 3/2 power. So here is our summary and justification. F of x has a point of inflection at x equals e to the 3/2 power because f double prime changes signs at x equals e to the 3/2 power. Part D. Find the limit as x approaches 0 of f of x. So they are asking us to find the limit as x approaches 0 from the right of natural log x over x. Quick side lesson, guys. You should have memorized what the parent function y equals natural log x looks like, and it looks like this. So based on this, I want you to basically memorize the limit as x approaches 0 from the right of natural log x, which comes up a lot. If you picture the graph, it is intuitive because as we get closer and closer to the y-axis, in other words, as x approaches 0 from the right, you can see that the function is falling, falling, falling. It is approaching negative infinity. Okay, so lock that into your head. The limit as x approaches 0 from the right of natural log x is negative infinity. So that's what's happening in the numerator of the limit that we are trying to evaluate. As x approaches 0 from the right, the natural log x is approaching negative infinity. Of course, the denominator, which is just x, is approaching 0. But what about the value of the overall fraction? Let's look at some examples to picture what's happening in the numerator. Imagine that we have -100, then -1,000, then -10,000. Meanwhile, the denominator is getting closer and closer to 0. When you take -100 and divide it by 0.01, that makes it even more negative. And same thing if you divide -1,000 by 0.001, that makes that even more negative, and so on. So this fraction is approaching negative infinity. So we can say that the overall limit as x approaches 0 from the right is negative infinity. Or I like to just say that the limit does not exist.